understand about various protocols that work behind these IoTs. Protocols means certain rules and regulations. Like every language, it has to follow certain protocols. Now, since here we are talking about so many devices which are communicating with each other with the help of various sensors, with the help of different networks. So, how are these devices going to interact with each other at a common platform? See, for example, let us say now we are suppose talking to each other. We are using a particular language, let us say English. So there are certain set of rules that we need to follow, that these are the particular grammatical rules that we have to follow for us to communicate in English. So that we can call protocols, certain rules and regulations that are developed for any uh, conversation or any uh, chatting with each other to happen. So in a very similar way, we have certain set of rules and regulations for these IoT architectures. If these protocols, they are being used as, there are different protocols, they can be used as per the requirement, and these protocols can be installed into our devices, and with the help of these protocols, the communication, it takes place. So here we are going to discuss about some common protocols that we use for this IoT system. The very first one is message queue telemetry transport protocol. The architecture of this protocol, it is very simple. We have a publisher, which can be the sensor or which can be actuator, which is delivering the information. And we have the clients at the other end, and we have MQTT, which will act as a broker or as a dealer to help these devices communicate. So probably the most widely adopted standard in the industrial Internet of Things to date, it is the message queuing telemetry transport. It is a lightweight publication subscription type protocol, messaging protocol. So basically, when we talk about this MQTT, so this is a lightweight publication subscription type messaging protocol. Publisher here would be the device from where the data will be published or data will be accumulated, and subscription we can call to the client who will access this device with the help of maybe his smartphone or maybe some other device. So the most widely adopted standard in the industrial Internet of Things is MQTT, that is called message queue telemetry transport protocol. Basically, it is designed for battery powered devices, and the architecture of this protocol, it is simple, it is lightweight, providing low power consumption for devices. See, we are talking about, suppose we have installed these IoT devices into our homes. We have lightning sensors, we have sensors into our refrigerator, into our at our ovens. So all these, they will be occupying some battery, some power. So this protocol, it is a very lightweight protocol. If this protocol, it is being used for designing or for manufacturing these devices, so it provides low power consumption. If we are using these devices all the times, they are operating all the times, so we definitely want low power consumption for these devices, because if there is more power consumption, it will be mere wastage of our power resources. So this MQTT, it is designed for battery powered devices, and since its architecture is very simple and it is lightweight, so it provides low power consumption for the device. So basically, MQTT, which is message queue telemetry transport protocol, it is a publication subscription messaging protocol. Then we have the next one, that is advanced message queuing protocol, AMQP. This AMQP specification, it describes such features like message orientation, like queuing, like route routing, including point to point, and publish and subscription technology, providing the reliability and security along with it. See, in this advanced message queuing protocol, we have here this message orientation technologies. This is a feature of this. We have the queuing technology. That means the messages, if your number of messages, they will be queued properly. We have this routing technology, routing feature. Routing will help the data to route from one device to another. That can be point to point. That means in the at one particular point to next point to the end point only. It will not deliver that message to all the devices connected. It will be only point to point. That means whatever devices they are communicating, the communication that will take place only among those two devices. So it provides us point to point transmission feature, then provides the same similar publishing and subscription technology, and it provides us with the reliability and security. How is this basic architecture of AMPQ is? We have the publisher, which number of publisher, which again are our sensors, which are attached into our various devices, maybe into our lights, microwave ovens, into washing machine, into geysers, or at different places we have connected. So these are the publishers. Then we have AMPQ, that is this advanced message queuing protocol carrier exchange. What will this do? This will exchange this message. This message, it will come from the publisher and it will be stacked into a proper queue. And then there are different queues, different messages queue. Since we have different subscriber, the output of all these sensors, they belong to different subscriber. So we have to queue them properly into different queues, so that the message which is communicated from the publisher, it reaches to the right subscriber. So we have message queues in which the message will be queued depending on the requirement and it will reach to the correct subscriber. This advanced message queuing protocol, it offers us two quality of service here. First is called at most once. Second is called at least once. In at most once, what happens? The sender here, the sender which is transmitting the message, it does not want having an acknowledgement from the receiver to delete a message. That means at most one, as soon as the sender it is sent the message, that message will be deleted from the queue. It will not wait for the acknowledgement to come from the receiver that he has received that he has received the message. That is why we call it at most once. The message, it will be delivered only once, uh, without any regard to that whether an acknowledgement it has come from the receiver or not. Another quality of service that it provides us is at least once. For each message, the sender, he will receive an acknowledgement from the receiver before deleting the message. In a case where the acknowledgement is lost, the message is resent. That is why we call it at least once. That means the message will be delivered at least once and the message here will not be deleted from the queue. The message here will reach to the receiver. He will send an acknowledgement of the message. When the acknowledgement is being received at the sender's end, then the message will be deleted. If the acknowledgement it is not received, then in that case the sender gets to know that the message has not reached to the receiver. He will resend the message. So that is why we call it at least once. So this is advanced messaging queuing protocol that we call AMQP, which may work behind your IoT devices. So here again we have the same thing. We have the publisher and we have the subscriber, and in between we have this carrier exchange, which will do keeping the messages into different queues, which will do this task that all the messages which are being delivered from the publisher, and they get stacked up into different queues as per the requirement. And again here, two types of quality of service is being provided, at most once and at least once. Then we have another common protocol that we may use for this IoT, that is DDS, Data Distribution Service. Here, as you can see from the architecture, we have just the publisher and the subscriber. It is almost similar to MQTT that we have talked about earlier. DDS, it follows the publisher subscriber methodology, with the main difference here that there are no brokers or dealers in between. It means that all the publishers, that means we have the temperature sensors or whatever sensors we have, they are the publisher, and the subscribers, which are our mobile phones, they are all connected to the same network. They are all connected at the same network, and this network, it is known as global data space, GDS, and it connects each node with all the other nodes to avoid the bottleneck. That means, like we have seen in earlier protocols, that we have a broker or dealer in between, which will sit between the publisher and the subscriber. But this is not the case with our DDS, Data Distribution Service Protocol. In this, we have a global data space. We have the whole network GDS, in which all the data from the publisher, it comes up and it will be delivered to the subscriber with no broker or no dealer in between. So DDS, again, it follows a publication and subscription methodology, but the main difference here is that there are no dealers and no brokers in between. So basically it avoids any bottlenecks. If more and more people are there sitting into the networks, that means there are more chances of traffic. There are more chances of bottlenecks. Since there is a direct communication between the publisher and the subscriber, so in that case there are less chances of bottlenecks being happening. Now, we have another important protocol that is called Constrained Application Protocol, COAP. Now, this protocol, it is designed to address the needs of HTTP based IoT system. HTTP, if you have heard about, if you've studied somewhere in the subject computer network, hypertext transfer protocol, which performs that is a protocol that is there in computer network, which performs the task of linking from one device to another. Hypertext, that means at one text we'll click, we will reach the next text. So it is similar, or this particular protocol COAP, it addresses similar needs of HTTP based IoT system, where we can click on something and we can receive the next result. We click on another thing and we get to know about the next result. So COAP, it relies on user datagram protocol for establishing secure communication between the endpoints by allowing for broadcasting and multicasting. This UDP, it is able to transmit the data to multiple hosts while retaining the communication speed and low bandwidth usage, which makes it a very good match for the wireless network. So this COAP, it provides us with the user datagram protocol. So it establishes secure communication between the devices. It allows for broadcasting and multicasting also. That means the same message can be delivered, it can be broadcasted to multiple users. It enables to transmit the data to multiple hosts while it retains the communication speed and low bandwidth usage. It does not use much of the bandwidth. So if we have the wireless network, so in that case this COP, it becomes very advantageous, it becomes very useful, because it is broadcasting the message to various users, as well as it is providing this advantage of using low bandwidth. It retains the communication speed also. So this protocol, it is very much useful for the wireless network, and it is used for HTTP based IoT systems. Wherever we have HTTP based IoT system, where we want our systems to connect to number of links together. So in that case, to address the needs of HTTP based IoT systems, we have designed this particular protocol that is known as constrained application protocol. Then the next protocol that we are going to discuss here is WebSocket. Now, linked to the HTTP protocol, the WebSocket technology, it establishes a TCP connection. That means a transmission control protocol connection between the browser and the server. And then both of them exchange data until the connection is closed. That means this WebSocket, it is again linked to the HTTP protocol. The WebSocket technology, it basically establishes a TCP connection. TCP connection between the browser and the server. This connection, it is being established between the browser and the server, and very easily both of them, they can exchange the data until the whole connection gets closed. So these are few protocols that are being used behind this IoT. Now these protocols, they help us to since there are so many devices connected together, they are all having different softwares, different systems working on together. So when they are exchanging their data, they have to all come to a single point of concern, point of thing, that all of them, they can communicate together easily. How this happens? This happens with the help of these protocols that are being discussed here. So these are the few protocols that are commonly used for IoT systems.